So in this video, we're going to talk about confidence intervals when we know what the standard deviation of the population is. All right, so far Chifaru, she knows how the central limit theorem works. So she knows how to take a sample large enough for the central limit theorem to apply, right? Greater than 30, so 31 or more. So she knows to take a sample large enough. She knows how to calculate her sample mean. But what she wants to know is, how can this sample mean be used to estimate the population mean, which is really the thing that she's interested in? All right, so what we've seen so far in class, right? If we only have a sample mean, we can't expect that to be the population mean, right? Sometimes it is, but most of the time it's not. So what we like to do is we like to calculate something else and look around our sample mean to try to estimate the population mean. The thing we calculate is called a margin of error. And we're going to call it M so that we have something that we can simply use to plug in to formulas. And we look on M on either side of X bar. Right? We take M away, our margin of error away from our sample mean. We add our margin of error onto our sample mean, and we try to find mu in this region, right? So we try to figure out where mu can be based on this information. All right, so that's what the margin of error is. It's this band that we look around X bar to find mu. Now, the margin of error is going to depend on a couple things. Number one, it's going to depend on how confident we want to be that mu is in the interval, right? The more confident we want to be, the wider this interval is going to get. This confidence is going to be carried by something called Z alpha over 2. It's called a critical value. We'll show a table of these in a little bit. It's also going to depend on what the standard deviation of our population is, right? Here we're assuming we know this. The more spread out our data is, the more error, right? The larger our margin of error is going to have to be. And lastly, it's going to have to depend on the sample size, okay? We've seen that the larger our sample size, the closer our sample means tend to be to our population mean, which is in this case the thing we're looking for. So the sample size is also going to have an impact on our margin of error. Right, so those are the three things that impact our margin of error. Now, let's take a closer look at exactly what it is, the margin of error we calculate. All right, so for us, our margin of error, which we're going to call M, it's going to be this Z alpha over 2 that's going to be our critical value. Remember, our Z-score was related to our standard normal distribution, where 68% of the data is one standard deviation away, right? So Z is plus and minus 1. Plus and minus 2 is going to be about 95%. We're going to refine that a little bit, so 95% is going to be something close to 2, plus or minus 1.96. Right, and then, right, more percent means our z's get larger, farther away. So our critical values are going to get larger. Sigma is our standard deviation for our population, and the square root of n is our sample size. So the square root of n is something we have seen before as well. Our Z alpha over 2, these are going to be called our critical values, and they're going to depend on the confidence level, right? It's all about the Z scores for how wide we want our center to be, right? For 95% of the data, right, it's going to be plus or minus 1.96. For 90, it's going to be a little smaller. Our Z's are going to be closer to 0. For larger confidence intervals, we need more of that center. Right? We need the wider piece. Right? These go out as our confidence increases. There's more inside. as our confidence level goes up, our critical value is going to have to increase, and so our margin of error is going to have to increase. Sigma is going to be our population standard deviation, right? That's this guy. And again, as our standard deviation increases, our margin of error will also increase, right? So Z and sigma, they behave pretty nicely. As they increase, our margin of error increases. N is, of course, our sample size, and that's the one that behaves differently. As the sample size increases, our margin of error decreases. And again, we saw that because the larger our sample size is, the more likely our sample means are to be close to the population mean. All right, so here's a pretty standard table of our critical values. Okay, for a 90% confidence level, our Z alpha over 2 is 1.645. All right, so positive Z 1.645, negative Z 1.645, about 90% is going to be in there. 95%, our Z's get a little farther out. 95% of the data is in here. As our confidence level increases, we capture more and more of the center in there. And we get a little wider range for our possible values. Okay. Right, and the way to think about this is the confidence level is the probability as a percent that a sample mean, right, our x bar, has a z-score within plus and minus z alpha over 2 of the true population mean. But the problem is we usually don't know the population mean in this case. We're trying to estimate it using our sample. So how do we use this? We use this by calculating something called a confidence interval. Right? We call the interval of our sample mean minus our margin of error, all the way up to our sample mean plus our margin of error, the confidence interval. Right? This is going to be some range of values. And depending upon the confidence level, what we say is we are, whatever our confidence level is, percent confident, that the true mean is between our sample mean minus our margin of error and our sample mean plus our margin of error. Now, in reality, what this is if we take samples of size n, right, the same sample size over and over, whatever our confidence level percent is of these confidence intervals will contain the true population mean. We're not actually guaranteed that the true population mean is in any of these intervals. But if we do this process over and over and over again, right, if we choose a 95% confidence interval, if we do this over and over and over again, 95% of these intervals will contain the true population mean. But the thing is, we don't know which ones right off the bat. So next, we're going to look at some calculations, and we'll see what this means.